Hello students, today's topic is Kerbos. So before starting the topic, I have to discuss some of the drawbacks related to the NSP protocol as well as the KDC. So the KDC protocol drawback is simple protocol KDC having some drawbacks like the replay attack. So in order to solve this issue, NSP protocol is developed, but there are some another drawbacks over the NSP protocol. Like in the NSP protocol, the RSA wants to communicate with the Bob. So first, it has to verify its authenticity to the KDC, and the KDC will be responsible. KDC is responsible for creating the session key between Alice and Bob. So in this way, if Alice wants to communicate Bob again and again or over some another entity, then it has to repeat the verifiable process like this one process have to be created many times, repeatedly many times, in order to communicate with each entity. So this is one of the drawback of the NSP protocol. In the drawback, what happens, the KDC server, this server will becomes very overloaded, means it has to do two things simultaneously, like authenticity of the entities as well as granting of the tickets and the session keys. So this is one of the drawback of NSP. So in order to mitigate this drawback, one protocol is developed that is called the Kerberos. So Kerberos is an authentication protocol which is used in Windows 2000 as well as Windows 7 or Windows 10, and it is initially designed by the MIT. Basically, Kerberos have many versions, and nowadays version 4 and version 5 is used. And the Kerberos is basically designed for client to server applications like your file transfer protocol, in which a client is used to communicate with the server in order to access any data, in order to access any file. So Kerberos is an authentication protocol which carries the KDC protocol techniques over there, but there are certain differences from the KDC or NSP protocol with the Kerberos. Like there are only three entities in the NSP. The first one is called sender, the second one is the KDC, like you can see the diagram of the KDC, sender, KDC and the Bob. But in this protocol, the Kerberos protocol will carry three entities like the same NSP, but this KDC entity is divided into two servers. The KDC entity will divide it into two servers. The first one is called the authentication server and the second one is called ticket granting server. So basic difference you can see in the Kerberos protocol, the functionality of the KDC is assigned by two servers. The first server is authentication server and the second one is the ticket granting server. So the work that performs the authentication of the entities is done by the AS only, and generating of the tickets as well as granting of the session keys will be done by the TGS. So just like the work distribution is done inside the Kerberos, so this one is called sender, this one is called server, means it is the client, it is a server, data server, and this one is the KDC, and the KDC functionalities is divided in two things. The first server is called authentication server and the second one is called TGS server. So this is the basic regarding the Kerberos, and I will elaborate what are the authentication server, what are the ticket granting server and the data server. Basically the Kerberos has three servers. The first one is called authentication, the second one is called TGS and the third one is called data server, in which the authentication server and the ticket granting server comes under the functionality of KDC, and the data server will be act as a receiver like Bob. So what the authentication server does, the authentication server, as the name indicates, authentication server AS is responsible for doing the authentication of the entities, means the sender. So what the authentication server does, authentication server makes registration of each entity. And creates username, creates identity and password. for each entity, creates identity and password for each involved entity. And after the creation of the password and identity, one session key will be generated. The session key, like in this protocol, this one is A and this one is the KDC. Because I'm talking about the AS inside the KDC, so actually you have to first see the diagram. Suppose this Alice A wants to communicate with the Bob B. So the first rule that the Alice has to verify its authenticity to the AS, and this AS is responsible for generating of the session key as well as ticket, which is valid for in order to communicate with TGS. So second one is the Alice should have to perform the communication with TGS, and the TGS is responsible for creating the ticket and the session key which is used to perform the communication with the Bob. So there are three rules, first one, second one, and the third one. So authentication server make the registration of each entity and creates identity and the password. After creation of the identity and the password, one secret key will be generated for entity, for the registered entity. Like if A performs communication to the AS in order to verify the authenticity, the first one, then what will be the secret key between the Alice and AS? The secret key will be indicated by K A and AS, like this one. This is called secret key. So after establishing of the secret key, it has also one functionality, that generating of the password, generating of the identity, generating of the secret key. Authentication server is also responsible for generating of tickets, and a session key that is used to perform communication with ticket granting server TGS. Okay, so when the ticket and the session key will be in the form of K and TGS. This is a session key which is established between the Alice and the TGS, and the session key is provided by the AS. So what is the functionality of the authentication server? The first one is it has to create the identity and the password. The second one is it has to create the secret key for each entity such that it can perform the communication with the authentication server directly. As well as the third task of the AS is to generate the ticket for TGS, and a session key between the involved entity and the TGS, KATGS, that is used to perform the communication with the TGS. Then what about the functionality of ticket granting server, TGS? So this is responsible, it is used to create session key between Alice and Bob. It is represented by KAB, and ticket for Alice and ticket for Bob, such that both entities will enable in order to communicate with each other. And last one is the data server. Data server is nothing but a server having Actify functionality. In this example it is Bob. So it is very simple. Authentication server creates authentication by creating of the secret key, by generating of the ticket for the TGS as well as a session key for the TGS, such that the entity and the TGS will communicate with each other. Then when the session key and the TGS ticket will be generated, then the entity, means Alice, will communicate with the TGC and request for generating the session key such that it can communicate with the Bob. And this TGS is responsible for creating the ticket for both Alice and Bob as well as a session key called KAB. And the data server is nothing but the FTP server. So what is the diagrammatical point of view explanation for the Corpus? So these are the entities. I already explained this diagram, and this one is the sender, this one is the receiver, means server, data server, and this one is the KDC. And the KDC having two entities. The first one is authentication server and the second one is the TGS server. Now just follow point by point, makes the registration of each entity and creates identity and password. So after creating of the identity and password, one secret key will be already generated. Okay, once the secret key generated, and Alice can communicate with the AS. So in the period communication, in the initial communication, Alice has to send the identity to AS. The identity which is created after the registration process, the identity which is created after the registration process, this one, after the registration process, this identity has to be sent in the communication. Like Alice has to send a plain text message in which Alice has to mention its identity Alice and send towards the AS. Okay, so after getting the message from the AS, what the AS will do, the AS will generate a ticket, the ticket for TGS. So when the ticket for TGS is generating, the entity should be placed inside the ticket will be Alice, and a session key which is used to perform the communication between sender A and TGC, means Alice and TGS. So what will be the session key? The session key will be T, and I think it should be more broader. So the ticket is this one, and it is Alice identity, and the second one is T, A and TGS, like this way. Also the copy of this session key, like TE and TGS, have to be appended in the message. This ticket will be encrypted. The ticket will be encrypted by using the, it should be K. It's not more visible, I think. I will create a diagram, block diagram, I think. So you can see this one is called ticket. The ticket contains the Alice identity. This is ticket for the TGS. So this ticket contains the Alice identity and the session key which is used to perform the communication between the Alice and the TGS. This ticket is encrypted by using the secret key of Alice and TGS, that is KAS and TGS, and the copy of the session key, that is KA and TGS, is appended in the message, and this whole message will be encrypted by using the secret key. The secret key is the one which is getting after making the registration process by Alice to the AS. So KA and AS is the secret key between the sender A and the AS, and this message will be sent by the AS towards the Alice. So this diagram will be like this one. Now after getting this message, because Alice having the key KA and AS after the registration process with the AS, Alice A can successfully decrypt this message. After decrypting, it can get the session key that is used to perform the communication with the TGS, because it's containing KA and TGS, and the ticket for TGS. By using the ticket, Alice A can prove that I am authorized person in order to communicate with the Alice. So what happened next? The Alice will request to the TGS that I want to communicate with the Bob. Kindly allocate me a session key between A and above B, and a ticket for both A and both for both Alice and Bob. Okay, I am repeating once again that Alice A has to communicate with the TGS, has to ask to generate a key, a session key between A and B, as well as it has to request TGS that please generate a session key as well as a ticket for both Alice and Bob. So how can the request take place? The request take place by using the a block having Bob's identity. The Bob's identity tell that I want to communicate with the Bob, as well as this ticket, the ticket value. This ticket will indicate that Alice is the authorized person to communicate with TGS. It is just like the appointment letter that you have to access before making communication with the higher authority. So this one indicates the ticket from the previous one messages. This ticket is used to indicate that Alice is the authorized person in order to communicate with the TGS server, and this rule message is encrypted with the session key, which is secret key, KAS and TGS, and another one the Bob's identity, because Alice has to make a request that I want to communicate with the Bob, and another one is called this timestamp, which is act as a nonce. So this nonce is used to prevent from the replay attack, because the session key generated by the authentication server and the session key is KATGS. So this nonce value has to be encrypted with the KATGS, and this message has to be forwarded from the Alice towards the TGS. So after getting this message, the TGS server having this secret key KAS and TGS. This AS is not the authentication server. Basically, this AS is the Alice secret key. It is a Alice secret key. The secret key, it is used to communicate between the Alice and TGS, not the session key. It is a secret key. So what happened after decrypt this ticket? TGS will get know about the Alice identity and also the session key KTGS. Now TGS will understand that Alice wants to communicate with the TGS, and Alice make a request in order to communicate with the Bob, and Alice wants a session key, and if TGS wants to communicate with the Alice, so the session key is KATGS. So now what is the functionality of TGS? The TGS functionality is to create a session key which is used to perform the communication between the Alice and Bob, which is indicated by key and B, and it has to generate two tickets. One ticket is for Alice and one ticket is for Bob. So how can we generate it? So this is the diagram. Two tickets have to be generated. This one is for Alice and this one is for Bob. So when the ticket for Bob is generated, then the identity element will be Alice and the session key is KAB, right? And this root message will be encrypted with, because it is for Bob, so the message will be encrypted with K T GS and B. So this is a secret key between TGS and B. And another one, the ticket is generated for Alice, so the identity element is Bob and the session key is KAB. Because I am generating the ticket for Alice, so it has to be encrypted with the session key. The session key is KA and TGS. And these two tickets have to be sent towards the Alice. Now Alice having the key KTGS, a session key, so now it is successfully done the ticket and the session key KAB and the Bob's identity, and it has to forward this ticket towards the Bob such that it can authenticate itself that I am the authorized person in order to communicate with the Bob. So how can this perform? Alice has to send a ticket which is generated for Bob, this one. This is generated for Bob ticket, and it is generated for Alice ticket. So Alice has to send the Bob ticket towards the Bob, and this value KGSNB, the secret key between the TGS and the Bob, is a secret key between the Bob and the TGS, such that Bob is the only person that is used to encrypt this ticket. And also in order to prevent from the replay attacks, it has to forward one timestamp unknown values like T value, and it has to be encrypted by using the session key, because the Alice has to communicate with the Bob by using the session key which is established by TGS KAB, and this value has to be forwarded from the Alice towards the Bob. Okay, this is very simple. And for the authentication point of view, there is only one thing is remaining. The thing is, after getting the Alice ticket, the Bob will authenticate. Bob will get to know that Alice wants to communicate with him, and that is KAB's session key. And if Bob also wants to communicate with the Alice, then Bob can use this session key. And now with this none's value, the timestamp message, it has to verify that this is not the replay type of attack. So in order to do that, in order to do the further verification, it has to send a none's value less than 1, like T minus 1, like in the previous example in the NSP protocol. T minus 1 value has to be forwarded towards the Bob, towards the Alice by the Bob, and this message will be encrypted by using the session key KAB, and this message has to be forwarded from the Bob towards the Alice. So from this Kerberos protocol, we have provided the prevention from the replay attack, as well as we do not need to verify the sender's authenticity to the KDC again and again. Just it has to do the verification for only once at the starting of the communication, and after that, if the Alice wants to communicate some another entities like Bob, Jack, Ruby, Sita, Geeta, then Alice do not confirm its identity to the authentication server again and again. Just it has to Alice has to make a request to the TGC directly that I want to communicate with the Geeta, then provide me the ticket as well as the session key. If Alice wants to communicate with the Sita, then Alice makes a request towards the TGC that I want to communicate with the Sita, kindly allocate me the session key between us as well as grant the ticket in order to perform the communication between me and Sita. So like in this way the burden overhead over the KDC will get reduced. The KDC will only used to perform the authentication by only once to a particular entity, and after that it will use to generate the tickets. So this is all about the Kerbos. If anyone has a doubt, kindly ask me in the doubt session. I think it is properly understood by all of the students. It is a very simple concept. So this one will become the first, this will become the second, and it will become the third. This is fourth procedure, and this is fifth procedure, and this one is called sixth procedure. So Kerbos is made up of 6 procedures. In the first one, the Alice has to make a request to the authentication server first time by its identity, registered identity. In the second rule, the AS has to grant a ticket in order to perform the communication with the TGS as well as a session key. A session key is KATGS, and this boot ticket will be encrypted by using the secret key that is indicated by KAS and TGS. It is not the AS of this one, it is AS indicates the Alice secret key, and this bool message will be encrypted by using the secret key which is shared between the Alice and the AS, so KAAS. So because Alice having the key KAAS after the registration process, so it is successfully decrypt this message and grant the ticket as well as the session key. So after getting the session key, it has to make a request towards a TGC. I want to communicate with the Bob, please grant me a ticket as well as a session key, by initiating a ticket value as well as the Bob's identity and the timestamp message in order to prevent from the replay attack. So this ticket comes from the previous message. Basically this is the ticket for TGS. So when the ticket for TGS is created, the Alice identity will be resided inside the ticket and a session key, that is KTGS, which is used to perform the communication with the TGS, and the secret key. Now the TGS will access this message. It get to know the Bob's identity, means Alice wants to communicate with the Bob, as well as there is a timestamp message, means it is not the replay type of attack, as well as it gets this ticket. By getting this ticket, it understood that the messages comes from the Alice and Alice wants to communicate with the Bob. So it issues 2 tickets. One ticket is for Alice and the second one is for the Bob. So for initiating the Bob's ticket, it has to decide the Alice identity inside the ticket and the session key KAB, and this whole ticket will be encrypted by using the secret key which is shared between the TGS entity and the Bob. And the second one is the ticket for the Alice, in which the Bob identity is resided and the session key is also resided, and this whole message will be encrypted by using the session key which is granting by the AS, that is KATGS. And in the fifth one, after getting the tickets, the Alice can communicate with the Bob directly by using the timestamp in order to prevent from the replay attack, and it sends the ticket to the Bob that, hello Bob, I want to communicate with you, this is your session key if you also want to communicate with me. And the Bob will finally verifies the authenticity of the Alice, and it has to send the timestamp value less than 1 in order to get sure that it is not the replay type of attack. I am also the authorized one entity and I am getting your session key successfully. So this is all about the Kerbos. Thank you.